The third example here, or the second example in this section, the sine of x is equal to 3/4. We're going to do the same thing. We're going to solve this algebraically, and then we're going to check it algebraically and check it graphically. Now here the sine of x equals 3/4 is not on the unit circle, so I can't even check my work ahead of time. I'm just going to have to go through and do this. So the first thing I'm going to ask myself before I do anything is, what quadrants will I be in? And here the sine value is a positive 3/4. So what two quadrants is sine positive in? And we know it's going to be in quadrants 1 and 2. So when I get to my reference triangle portion a little bit later, I'm going to be using quadrants 1 and 2. So in order to solve this, I need to get x by itself. So we'll take arcsine to both sides. Sine and arcsine cancel, so x is equal to the arcsine of 3/4. And we'll take our calculator and we'll find out what that is. So second sine of 3 divided by 4. And we can see that's about 48.59 degrees. So x equals 48.59 degrees. That's what I think my first answer is. My second answer is going to be in the second quadrant. That 48.59 is the first quadrant answer. So when I draw my reference triangle, I know my first answer right here is in the first quadrant, 48.59. My second answer is going to be in the second quadrant. And remember, we always base our reference triangle off the x-axis. And this angle measurement is congruent to that angle measurement. So this is 48.59 as well. We know that's 180 degrees. And since I want to measure in the counterclockwise direction to that line, I see that angle is less than 180 degrees. So to find that angle measurement, I'm going to take 180 degrees minus 48.59, which will give me 131.41 degrees. So there are my two answers in the first and second quadrant. Let's confirm that this is accurate. We'll check algebraically. So we are saying the sine of 48.59 is equal to 3/4, and we're saying the sine of 131.41 is equal to 3/4. We're plugging in our x values back into our original, and we're going to check. Now we know 3/4 is 0.75. Are we close to that? And we won't have the exact number because we rounded to 48.59 there. So the sine of 48.59, if we look at that, 0.74999, that's really close to 0.75. So we've got 0.74999. And then if we do the sine of 131.41, how close are we to 0.75? And you can see I get the exact same number right there, 0.74999. So that one worked out properly. And then to check graphically, we'll do the same thing that we did last time. y1 is going to be the sine of x. y2 this time is going to be 3/4. So we'll go back to our y1 and y2, and we'll do the sine of x and 0.75. And this time my window is still saved from the previous problem, so I don't need to go second zoom trig. And there's my graph. And once again, since I'm from 0 to 360, all I want is going to be this piece. And there's the two lines that I've got. And there are my points of intersection. I can sort of see them right there. So then we'll go second calc, intersect, and I'll scroll as close as I can to that intersection. I think it's 48.59, so 45 looks close enough. And we'll do a little guess. And sure enough, there's my 48.59 that I was looking for, and 0.75 is the intersection. And then we'll just confirm my other intersection is this 131.41. And sure enough, 131.409, that rounds to 131.41. So right here I can see this point of intersection is 48.59 degrees. This one is 131.41 degrees. So I've checked this problem algebraically and graphically, and I got my two solutions.